Welcome to Beyond Chips, the Chips GU podcast, where we explore people, projects, and partnerships shaping Europe's semiconductor future. I'm Luciano Gaudio, Head of Communication at Chips Joint Undertaking.
And I'm Vasily Peglidou from the communications team. Together, we'll be your hosts as we speak with researchers, innovators, and industry leaders behind the technologies powering Europe's digital and green transition.
In every episode, we'll go behind the scene of Chips GU founded projects. We'll hear stories of collaboration, innovation, and real-world impact, from lab to the fab and practical application.
Whether you're part of the Chips GU community or just curious about how semiconductors are quietly transforming everything around us, from farming to mobility, you're in the right place.
Our conversations are guided by a shared principle: clear, respectful, and inclusive communication, just like how we work every day here at the Chips Joint Undertaking.
So let's get started and meet the people behind Europe's chip-powered future. Welcome back to Beyond Chips. In today's episode, we continue our discussion on FAMES, one of Europe's key pilot lines for advanced semiconductor technologies, and we're here together with Susana Bonnetier today. We'll explore what it takes to build and operate such a large-scale pilot line, from collaboration across the industry and research partners to ensuring that technologies developed can be manufactured and used effectively in Europe. We will also look at how the FAMES ecosystem brings together expertise and innovation to strengthen the European semiconductor value chain. Susana, what makes FAMES a pilot line, and how does it differ from typical R&D projects?
Thank you, Vasiliki. Yeah, I'm very glad to be here today with you also. Well, as you know, FAMES is one of the pilot lines of the European Chips Act. It's financed by the Chips GU, and it's operated by a consortium of 11 European leading research organizations and universities. So you asked me what makes FAMES a pilot line. I would say that it's a pilot line because it acts like a bridge between the R&D of advanced technologies and their industrialization. And this is really the heart of what the pilot line should be. And the idea is to bring those technologies closer to the market. I would say, to answer your second question about the main differences between the FAMES and other more typical projects, that it's really two things, I would say: the size and the significant budget to purchase new clean room tools. The overall financing of the pilot line is 830 million euros, half of it being funded by the European Commission through its operator, the Chips GU, and the other half by the national authorities of the participating countries, which are the countries where the FAMES partners are located. And of these 830 million euros, almost half is destined to the purchase of new state-of-the-art 300 millimeter clean room equipment. And these tools are really the same or equivalent to what you would find in a semiconductor foundry today. So it means that when we develop things on the pilot line, then foundries can pick it up quickly, companies can adapt easily what we've done to their use cases. That's one big difference. I would say another one is the open access feature. This open access feature is really going to encourage users to benefit from the pilot line early on in the program. And finally, I would say it's the training aspect that also is very important here, because with the training, we're really going to facilitate the adoption of the FAMES technologies by both companies and academics.
Thank you, Susana.
Susana, how does a FAMES open access framework function? Reactive request versus annual open calls? Please explain a bit more.
Sure. So the open access is really giving access to the R&D services that are available thanks to the pilot line to users, to the stakeholders of the European semiconductor ecosystem. So what are those R&D services? They can be things like PDKs that are either to have access to silicon or to simulate chips when designers are thinking about the new architectures. They're also the results of our demonstrators, advanced semiconductor processes, characterization and testing capabilities. This access is aimed primarily at European electronic value chain stakeholders, including academic research teams, SMEs, startups, and large industrial groups. Our goal is really to offer FAME's pilot line users the possibility of exploring new markets by using these new FAME's technologies. And so by doing that, we would strengthen, of course, the European semiconductor leadership. So users interested in accessing the FAME's pilot line can do so. They can file a submission form on the FAME's website, which is open to everyone, or if they prefer, they can contact a FAME's partner directly. To encourage and facilitate this access, once again, the FAME's team organizes open access calls every year. They go from March to May, and the first one was this year. This year we launched the first open access call with a dedicated workshop that took place in Brussels and was open to all European semiconductor stakeholders. We had 120 participants. We were very pleased with that, and they came from 25 different countries. And as I mentioned, these calls will take place every year in springtime. So if you missed the first one, don't worry, come to the second one. We'll be there and we'll have a new offer. So potential users can also submit a spontaneous request. So Luciano, you had called these more reactive requests and proactive. These were the terms that we had in the proposal. Proactive has become the open access calls, and reactive is now called a spontaneous request, so that users really feel that they have access to this pilot line all year round, even though the open access call moment is a privileged moment to gain access, because there are some technologies and PDKs for MPWs that are coming on at a certain period of time. And if you don't get in during the call, it's difficult to have access to the MPWs. So the call is really a highlight. But then during the year, users can have access to spontaneous requests. And there they can request the kind of technology they're looking for. And of course, they will be in contact with experts from the FAME's pilot line. And I would say that most of the spontaneous requests concern longer R&D programs. These are really programs that are intended to tailor a FAME's technology to a particular use case. And in the case of the open access calls, people are really looking at what's, let's say, on the menu of the technology portfolio. So how can users reach the FAME's pilot line partners? They can do so directly, or they can also consult the CHIPS JU competence centers, which are coming on. Some are younger than others, but they will be up to speed, we expect, in mid-2026. And these can be local resources for users also to gain access to the FAME's pilot line. Other than the pathfinding or simulation process design kits, which are kits where you have design rules that will help you design something, but if they're pathfinding, that means they're simulation PDKs, these are free of charge. What you have to do is sign an NDA and sign a license agreement, and you get these free of charge, since really the work is going to be done by the designer using the design rules. But the other technologies, aside from that one, do carry a price. And once we understand your needs, then one of the commercial team of the FAME's pilot line will be in touch to put together a technical and financial proposition.
There's definitely a lot of opportunities and different means for people to access and make their requests. So I think that's something really important, that you make this available and you make it easy enough as well for people to access. Because at the end of the day, this is part of the purpose of the FAME's pilot line. But you mentioned the different stakeholders and partners. How does the distributed pilot line operate across the multiple European sites? Does this have something to do with the partners and where they're located?
I think it has more to do with the specificities, the expertise, R&D expertise of each of the sites. And also, one thing that I'd like to mention is we are 11 partners. And among the 11 partners, there are 4 that we call hosting sites. These are partners that have benefited from the capital expenditure. So they have new clean room tools coming into their sites. And this is going to enable them to have a richer offer for the users. And then there are what we call the expertise partners that are bringing their expertise, but also their existing clean rooms, which were sufficiently equipped to satisfy the needs of the different technologies that we're developing in the FAMES pilot line. So does it have to do with geographical location? Not so much. It will have to do with what the user requires and where those R&D capacities are located.
Thank you, Susana. A focus, let's say, on specific users like small and medium enterprise, startups, or academia. Is there any difference in accessing this pilot line considering these different kind of users?
Yeah, so we've learned to adapt our offer to SMEs, academics, and startups, knowing that academics, they're working either for a thesis or a postdoc, and there's a reduced budget in a way. For SMEs and startups, the time factor is very important. And our commercial team is used to taking into account this. We do give privilege to SMEs, academics, and startups if there is an overflow of requests. When it comes to costing, the pilot line has to cover its costs. So the pricing will be the same, but we will look for ways maybe that there are academic collaborations for the academics, and we'll be looking at quick wins and quick deployment solutions for SMEs and startups. But otherwise, the access is the same for everyone.
One more question about the technologies. You already mentioned some of them. So I'm wondering, how has the consortium managed the compatibility across these different technologies like FD-SOI, the embedded non-volatile memory, radio frequency or 3D stacking, PMIC? Could you briefly share something about this?
So I would say that first, different elements that make it possible to work on the different technologies with different partners in different locations and different expertise is that we do work together on the R&D project on the different topics organized in work packages. So, of course, the work packages are specific to each one of the topics, and there are task leaders for the different tasks of a single work package that come from the different partners and RTO and universities. So we are constantly interacting on the contribution of each person to bring in a whole result. And this is a very important feature that is conducive to interoperability and working together. Thinking about all of these different aspects has really made us work together and understand the relation and the benefits of using one technology or the other. How can they be brought together? How can we offer them as a sum of different options that users can benefit from?
That's exactly what I meant with my question as well. How can we bring together these technologies and make them function in a way that is necessary?
Susana, geopolitical dimension, strategic capabilities are all crucial aspects to take into consideration. How does a FAMES support European technological sovereignty in semiconductors?
Well, the EU Chips Act was adopted in July of 2023 to address key challenges that we were facing at the time as a semiconductor industry in Europe. One was the component shortages that we had felt very, very, let's say, sharply during the COVID period, and especially for the automotive industry, which is really Europe's main chip-consuming economic activity. To be able to find solutions to those shortages, what better way than to try to produce them in Europe? So we wanted to reduce the dependency on foreign suppliers by supporting European-made technologies and, of course, more sustainable technologies. And also, by doing that, we wanted to create good quality jobs and business opportunities in Europe. So how does the FAMES pilot line contribute to this goal? Well, we support the emergence of high-performance technologies that have been made in Europe. We have what it takes in Europe. For example, the technologies we are developing are being used in low-power integrated circuits for higher efficiency microcontrollers. Also, they're enabling new computing paradigms. They're also responding to the needs of the upcoming 5 and 6G devices. Printed inductors for more compact DC-DC converters are also attractive solutions. And with the 3D integration technologies, we are really enabling new chiplet architectures. So really, the goal of the FAMES initiative is to establish a domestic semiconductor pilot line for those cutting-edge microelectronic technologies and make them readily available to stakeholders of the European electronic value chain. But we should really also take care of the European electronic value chain, and the open access mechanism and the training is also going to help with this.
Another one of the goals, of course, in Europe, but also a little bit more general, is to be more sustainable. What sustainability measures are integrated into the pilot line operations?
So yeah, a real concern for all the actors of the semiconductor value chain is the environmental footprint of the semiconductor industry. And this in terms of power and water consumption, greenhouse gas emissions, and the use of rare metals. This is really a great testing ground to develop eco-friendly best practices and work on resource optimization. So how are we going to do that? I would say that our plan is to develop eco-friendly best practices from the chip design stage to the technology industrialization stage and facilitate the adoption by companies that are interested and ready to do so.
Susana, just to address one of the most important matter, in my opinion, skills shortage. Tell us about the FAMES Academy. How does a training or summer schools foster skills developments here in Europe?
In the FAMES Academy plays a strategic role here because we're creating educational programs in advanced microelectronics to provide these new skills and tools to engineers and technicians. And this will really help facilitate the adoption of FAMES technologies by industry and academia alike. You started your question by saying the shortage of human resources in semiconductors in general. Some of the partners in the FAMES consortium are, of course, educational organizations that are training the youth to be the future semiconductor engineers and technicians. This is not part of what the FAMES pilot line is covering, even though we are interacting with these organizations to interest graduate students in coming to our training courses. What we try to do is to make it easy for them to see that they can go from their theoretical training as engineers to being an applied engineer in the area of semiconductors and learning how to design, use the different design rule manuals and tools so that they can enter the microelectronic business. But I think in general and activity, when I say business, I'm really thinking about all the way from academia through maturing research organizations, all the way to industry and to the market. I'm not excluding academia from the word business, and we all contribute to putting things in the market. So if you go to the FAMES website and you click on the training page, you'll see all the workshops, schools, courses, and webinars, and also the tutorials to come that are currently available. So we're working with these universities whose specialty is semiconductor R&D and semiconductor education to create courses that are more in tune with the offer of the FAMES pilot line, but that are taking into account everything you need to be part of this semiconductor industry.
Thank you, Susana.
We're almost at the end here, but I do have a couple of more questions. And I wanted to know if you have had any feedback or early uptake of the technologies from industry partners, and what might this be?
This is the semiconductor industry, right? It can vary a lot. So you really want to have recent information. And so we have constructed our external industrial advisory board. And this is a body of companies and I believe also some academics that are going to help us align with the industry's needs and also the new opportunities in early research coming forward so that we can really meet the expectations in terms of advanced technologies. And I would say to end that it's been really encouraging to read recent press releases from FAMES users. And I would take, for example, the press release from Soitec, which talks about our future collaboration on secure IC design. The article states that the FDSOI's proven advantages against laser fault injection attacks, we're talking cybersecurity here, due to its thin film architecture and channel isolation, provide a compelling foundation for next-generation secure IC design. And this is a quick lab-to-fab demonstration of what the pilot line is capable of providing. I think it's very encouraging, and I think you'll be seeing other press releases coming up soon. We're very, very excited about that.
Susana, how would you measure FAME's success for both users and the pan-European semiconductor ecosystem?
There are several ways in which we're going to be measuring the success. And once again, the first one will be when all the 100 tools are qualified and up and running and performing as planned, because this will be the basis of us being able to serve as a FAME's pilot line. Also, the results from the R&D projects, of course, that will be coming out, and those will be part of our newsletter. I'd like to take this advantage to say that we do have a newsletter where we keep up the news of everything that's coming out on the FAME's pilot line, the recent tech transfers. So this will also be, in a way, a measure of the success. You can read the newsletter and see how the FAME's pilot line is progressing. I think the number of users we can serve with the pilot line and the subsequent industry uptake is also an important measure. And so we've included a success story, tech transfer, in the newsletter also. And I would say, thirdly, by the technical and scientific results. So we have a good mix of science and, let's say, maturing technology to get to the market. And we remain in our initial training scientists and R&D researchers. And so we will be, of course, including the number of scientific publications, patents, fruitful academic collaborations, which are key to really producing the right technology in the right way at the right time, inspired by a lot of the early research that's happening in semiconductor labs. And of course, we will be looking at all the key performance indicators that were put into place with the FAME's pilot line that allows us to track its progress.
Thank you, Susana. And of course, count on us to share the newsletters and the press releases with the public. And just the last question. I'm wondering how and if it would be possible for a distributed pilot line of this scale and complexity like FAME's to be feasible without a support like the CHIPS-JU support. And what has the funding that you received from us enabled you to do that you simply wouldn't have been able to do otherwise?
Well, Vasiliki, I have to say that it really simply would not have been possible without the CHIPS-JU support. The FAME's R&D pilot line program really combines the expertise of 11 FAME's partners. Bringing them together, having them work together is a European scale project. And I think only the European Commission and the CHIPS-JU, the way they're set up to bring partners together to work together, is key. I don't see how we would have done that part, just bringing the team together. Additionally, there has been this enormous investment that we were talking about in clean room equipment. And you need to have a serious budget to be able to do that. It's unlikely that any country alone could have fostered this. I think it's really at the European level that we need to be thinking about these new developments to be able to push forward new advanced technologies. So, as I said earlier, one of the unique features of this CHIPS-JU FAME's pilot line is the balance between CapEx, investing in your tools, and OpEx, investing in your R&D, bringing together science and technology. That is really has been key in order to be able to imagine the R&D programs, bring them forth, execute them, and be ready to serve and transfer to the industry. So I would say, once again, no, this simply would not have been possible without the CHIPS-JU support.
Makes us happy to know that we are enabled such work.
Well, big thanks. I really am speaking in the name of the whole consortium. how grateful we feel that we are able to express our talents and the love we have for this industry and for the research that makes it possible, because you're giving us the tools to do that.
Susana, thank you very much for your kind words that you have used to express our added value and the importance of work that we are doing together. This is one of the elements that I would like to emphasize once more. I really hope that we will have the time to go back to FAME's success in a very short time and make an evaluation according to what you have indicated and explained. I'm pretty sure that this is the right direction, and we welcome you again at the next episodes for additional information about what you are achieving. Thank you very much again.
And thank you, Vasiliki and Luciano. This was great, a great opportunity to speak about something that I'm really impassioned about and that motivates me every single day.
Thank you, Susana.